Hi everyone, in the previous video we talked about the first two steps of the free radical substitution mechanism, the initiation step and the propagation step. So in this video we are going to talk about the termination step. Alright, so the termination step is very simple. Okay, all you need to know is that you will take all the radicals from your mechanism in the previous steps and combine them together. Alright, so all you need to do is to take the radicals and combine them together. Alright, but there are some tricks that I want to teach you here. Alright, so sometimes you'll see questions that will ask you about the MR, alright, or the relative molecular mass of different products. Alright, so there are a few things that you can see. Okay, sometimes you will see MR of HX, alright, depending on the halogen that you use. Okay, you will see this MR. So this could be one of the possible products. And sometimes you will see MR that looks like it has approximately doubled, and it's doubled minus 2. Alright, this suggests that it is the RR bond. Alright, so what do I mean by this RR bond? Is where two alkyl radicals combine together. Alright, so that is what we are going to see. So let's continue. Let's look at this question here. Alright, and choose the most stable product to continue with our discussion. So this was our most stable product, and these are our radicals that we have formed right now. So we have chlorine radical. Okay, we also have this radical. Okay, so there are a couple of ways that we can combine them to form our radicals. In fact, there are three ways that we can do so. Okay, so the first way is where we take chlorine radical plus chlorine radical to give you Cl2. Okay, so these two can join. Alright, another way is to take my chlorine radical, react with this thing, and it will give me my product again. And the last way, okay, is to take these two, and what I will do is, it is just like joining the dots that we have done when we were kids. Alright, you just point the dots to one another, okay, and you connect them. Okay, I'm going to show you this process again. You have a dot here, you have a dot here. Okay, you want to join them together, so erase them away, connect these 2 points. Alright, so that is how you can draw this, point the dots to each other, then you connect them together. Alright, so this is the termination step of the mechanism. Alright, so how can we tie in everything into a question? Alright, so usually there will be questions that will test you on the amount of the ratio of products that will be formed. Alright, so how do we calculate the ratio? Alright, we have to use two different things. Okay, we have to look at the propagation step. Alright, and also we also have to look at the number of equivalent hydrogens. So there are two factors, right? Number of equivalent hydrogen. Okay, then the other one is in our propagation step, which is our stable or more stable radical. Alright, so I mentioned in the previous video that the more stable radical will have a higher chance of being formed. Okay, so the rate of reaction of that will be higher. So let's compare these two radicals here. Okay, so in the radical on the left, alright, what we can see is that in this molecule, alright, I'm going to label two different groups of hydrogen atoms. Alright, and you should be able to tell that if I label the purple hydrogen, okay, as A, and the red hydrogen as B, the ratio of A is to B will be 6:2. Alright, so this is what we have based on the number of equivalent hydrogen atoms. So what about stable radical? Let's say, alright, in the data shows you that the rate of formation of this radical is 20 times of the rate for the second one. Alright, so how do I know the proportion of products? Okay, so the rate of formation, alright, is this. Okay, so you can form both of these radicals, but the secondary radical has a higher chance of forming. Okay, has a faster rate of reaction. So what we can do, okay, so this is our A and sorry, this is our B and this is our A. So at the end of the day, to find the proportion of product, okay, we just look at A is to B. Since they are both of these events are independent, all right, so I can just use 6:2. Okay, then I multiply by 1:20. Okay, this is the rate. All right, so I'm using step 1 here, I'm using step 2 here. All right, and the final proportion is 6:40, which is also equal to 3:20. All right, so this is how we can use the whole mechanism to answer questions about the proportion of products formed. Okay, so with this, I have covered the whole of the free radical substitution mechanism. Thank you.